Okay, we're back talking about rules of exponents, and there are just a few more examples I want to do. I'll start with these two, and then I've got a couple more written down that I'd like to show you. So let's take a look at using those rules that we highlighted in the previous videos. And notice that I have a couple things here separated by an addition, so I'm going to go ahead and do both of those simultaneously. Over here inside the parentheses, it looks like I can do a little simplification first, so let's start there. So then I have 3 times, the 2 times the 3 can be multiplied, 6xy to the 4th, parentheses, squared on the outside, plus anything to the 0 power is 1. So it doesn't matter that there's a variable in there. There could be a Shakespeare play in there. It doesn't matter. If it's to the 0 power, then it evaluates to 1. Anything to the 0 power is 1. Okay, in the next step, I'm going to need to distribute the power to the powers. I'm going to distribute this outside power to the powers of the things on the inside. Since they're all being multiplied, that's okay. If you don't see a power, you can put a little 1 there, 6 to the 1st power, x to the 1st power, just to illustrate, just to remind yourself that you're multiplying this 2 on the outside by those powers. Okay, power to the powers. So then, this comes out as 3 times 6 to the 2nd power, x to the 2nd power, y to the 8th power. And I still have plus 1 there on the end. Okay, let me evaluate the 6 squared part of that. So we've got 3 times 36, x squared, y to the 8th, plus 1. And now I can do this 3 times 36. What's that, 90 and 18, 108. So this comes out to 108 x squared, y to the 8th, plus 1. And that's it right there. Okay, for the next example, I wanted to highlight this to show you how you can quickly manipulate negative exponents regardless of whether they're showing on the numerator or the denominator. So recall that the negative exponent rule says a to the negative n is equal to 1 over a to the n. Right? Now, from here, you can actually determine that it's also true that a to the n is equal to 1 over a to the negative n. So what does that mean? In the first case, if you look at a to the negative n over 1 as a fraction, then if you take it down to the denominator, the power becomes positive. If you look at a negative exponent in the denominator, if you bring it up to the numerator, like this, the power becomes positive. So the really quick way to deal with this x to the negative n over y to the negative m, if I want to rewrite it without negative exponents, is to simply take that x to the negative n down to the denominator as x to the positive n, and take that y to the negative m in the denominator up to the numerator to make the power positive, and there it is. And that's just a nice fast rule to be able to shuffle things around. Okay. Now you could have showed this in another way. For example, here's one other way to do it, just to connect it with this initial definition and some maybe previous knowledge that you have on the topic of fractions. I could say that this is 1 over x to the n, right? And on the bottom, 1 over y to the m. This is certainly true. All I'm doing is following this first rule. Now, if I'd like, I could rewrite this as 1 over x to the n divided by 1 over y to the m. This is the same exact expression. And I like to remember a little rule here when I'm dividing fractions, or a little phrase, I should say. The phrase is copy dot flip. I'm going to copy the first one, dot, flip the second guy over. And that seems like magic, and I'm stating it without proof. So if you'd like, take it from here and end up with the final result of y to the m over x to the n by a clever multiplication of 1, I should say. So take some time, see if you can do that. But remember, you can just copy the first one, multiply by the reciprocal of the second one, copy dot flip, and that's also valid. So there are these two examples. Here's our final result, the same as that one, which makes that handling those kinds of things really nice. And let me give you a couple more examples where maybe we can use some of this other stuff here. So let me take a moment to erase. I could stop the video, but then it wouldn't be as fun watching me erase this piece of glass. That's like 800 pounds. And who knows what gets said in between, you know? You could fast forward, but you might miss something. I don't know. It's up to you. You're probably wasting your time on YouTube anyway, in between watching math. What else are you checking out? How dogs can fly with rockets and airbags, or I don't know. Okay, don't try to make a dog fly like that. Poor hounds. Okay, almost there. Okay. All right, here are a couple other examples that I'll take a moment to write down. 2 to the negative 3, parentheses, x to the 4th, y to the negative 3, in parentheses, all of that is to the power negative 2, and then we'll stick a z there on the outside, and that's the numerator of a fraction. The denominator is 8, x to the negative 5, y to the 15th, z to the negative 3. Okay, and then I've got one more example, a simple numeric example after this. But so what do you do if you see something that looks kind of crazy? It's not too bad. There aren't any pluses or minuses. It could be a lot worse. So there are different approaches, and when you see something complicated like this, when you're applying those rules that I showed in the first place, there are so many ways to get to the final correct simplified version that you may be going a different path than the person next to you, a friend that's taking the same class, whatever. But as long as you follow the rules correctly, you will get to the same result when you simplify fully. So, how do I want to start? Let me start with an equal sign. And I'll just recopy my fraction bar. That's probably going to be retained. This 2 to the negative 3, let me bring that downstairs and call it 2 to the positive 3. So I'll start there. Okay. Now, still looking at the numerator, I will distribute the power to the powers right away. I could even bring this whole thing down, but I'm not going to mess with that. Let me just start with distributing. So this gives me x to the negative 8, y to the positive 6, and I still have a z up there. Okay, on the bottom, I've got an 8, so I'm going to say times 8. When this 2 to the negative 3 comes down, it's 2 to the 3rd power. It gets multiplied by that. X to the negative 5th, I'm going to go ahead and take that upstairs here, times x to the positive 5. I take it upstairs, it becomes positive. The y to the 15th remains, or I just feel like keeping it there. The z to the negative 3, I'm going to bring that up to the top and multiply by z to the positive 3. And now keep simplifying from here. Okay. On the top, x to the negative 8, I'm going to bring that down. So here's my new fraction bar. I'm going to bring that down as x to the positive 8. Y to the 6th, so I'm totally just looking at the numerator first. Y to the 6th, I could say that y to the 6th over y to the 15th, if I use the subtraction rule, becomes y to the 6 minus 15. And y to the 6 minus 15 is y to the negative 9th, which is 1 over y to the 9th, which makes, the y in the denominator there. So here's a clever trick. You can do the subtraction rule in reverse. You can say, okay, let's just do 15 minus 6. That's fine. 15 minus 6 is 9. And you're going to keep the power of y as positive in the place of wherever that larger power was. So the interaction of these two guys, y to the 6th and y to the 15th, produces y to the 9th on the bottom. Okay. If the 15 were on top and the 6 were on the bottom, then I would leave a y to the 9th on the top. That's just kind of a fast, nice way to get to handle that situation. Okay, the z's. Z times z cubed, z to the first power times z to the third power is z to the fourth power. And how about that x to the fifth? Oops, I forgot about that x to the fifth. I wasn't paying attention to him. Okay, so I'm just going to leave him there. I probably should have dealt with these two guys since he was there, but oops, no big deal. Just keep going. So I've looked at the numerator. Let me look again at the denominator. I've already handled the y's. 2 to the third power is 8, so this becomes times 8, and I still have this other 8 times 8. So in the next step, I will simplify that. And also in the next step, I'm going to deal with this situation. Okay. No big deal. Let me leave my z to the fourth up here and see what happens. And I'll use that subtraction rule in reverse again. So 8 minus 5 is 3, but since the higher power is on the bottom, that x cubed lands on the bottom. And I still have a y to the 9th. And 8 times 8 is 64, so this is times 64. And that right there is actually fully simplified. I could leave it like that. Oftentimes you'll see numbers in front of the variables, so you might see it written this way. X cubed, y to the 9th, and there it is like that. And the other one was fine too. Okay, so here's an illustration, especially with my ignoring the fact that there were two x's up here and I could have added those together. Here's an illustration of, oops, I took a different path, but I still followed the rules correctly, and so came up with the correct simplification. Here's another one. Let me give you a numeric example that might look ugly to start with, and I just want to show you how you can use the rules of exponents to make quick work of it. Suppose I had something like 888 to the third power over 222 to the third power. Okay. Now, if you were to try to evaluate those numbers first, as the order of operations tells us, then that's some gigantic number, and so is that. And then you can reduce, but I don't feel like writing out all those numbers, and I don't need to. In fact, I can rewrite this as the following: 888 on the top over 222 on the bottom, all to the third power on the outside. So notice that I factored out the power of 3. I undistributed it, essentially. You remember from the rule that you can distribute the power to the powers for a fraction. So certainly this is true to reverse that operation. Now what makes that nice is that these two guys, of course, reduce nicely. 888 divided by 222 is simply 4. So this becomes 4 cubed, which is just 4 times 4 times 4, which is 64. And we made nice work of that without having to deal with the large numbers that were produced there. So, it's been fun. Stay tuned. We'll do some more videos on exponents.